Here's a measurement that sounds impossible until the engineering makes sense. A modern, cold climate mini-split heat pump operating at 5 degrees Fahrenheit outdoors delivers 2.5 to 3 units of heating energy for every unit of electricity consumed, producing comfortable home heating at efficiency levels that conventional gas furnaces cannot match even at their best. At milder outdoor temperatures, efficiency climbs to 4 or even 5 times. Input electricity, making mini-splits dramatically more efficient than resistance electric heating, gas furnaces, or oil boilers across the entire heating season. The same equipment reverses operation in summer to deliver cooling performance matching or exceeding the best central air conditioning systems. The combination of exceptional heating efficiency, excellent cooling capability, and flexible ductless installation makes mini-split heat pumps one of the most compelling residential HVAC technologies ever developed. Understanding how mini-splits work, what their application involves, and where they fit contemporary home systems helps explain the dramatic adoption acceleration across cold climate markets where they were considered impractical just 15 years ago. The fundamental physics of mini-split operation applies heat pump refrigeration cycle principles in flexible ductless configurations that serve individual rooms or zones. An outdoor compressor unit connects to one or more indoor units through small refrigerant lines routed through building walls. The indoor units blow conditioned air directly into rooms without requiring the extensive ductwork that central systems demand. The ductless configuration eliminates the 20 to 30% energy losses that typical residential ductwork experiences, substantially improving overall system efficiency beyond what heat pump technology alone provides. Variable speed compressors and fans modulate operation to match actual loads rather than cycling on and off at Wexinduo, producing more consistent comfort while further improving efficiency. The cold climate performance advances that have transformed mini-split applicability represent remarkable engineering progress over the past 15 years. Early heat pumps struggled below 25 degrees Fahrenheit, transitioning to backup resistance heating at temperatures where heat pump operation became uneconomic. Contemporary cold climate mini-splits maintain strong performance to -5 degrees Fahrenheit, with some models operating effectively to -22 degrees Fahrenheit. The cold climate capability has opened dramatic expansion of mini-split applicability to northern regions where the technology was previously impractical. The engineering advances include variable speed compressors, enhanced refrigerants, and sophisticated defrost cycles that collectively address the performance limitations of earlier generations. Dr. Thomas Reichenbach-Huber, a Swiss mechanical engineer who has studied heat pump performance across diverse climate conditions for over 20 years, has documented how contemporary cold climate mini-splits consistently deliver seasonal coefficient of performance values between 2.5 and 4.0 in northern climates, substantially outperforming conventional heating alternatives on both efficiency and emissions measures. His research at Swiss technical institutions has contributed to European performance standards that progressive manufacturers now routinely meet or exceed. The Research Foundation supports continued market growth by providing evidence-based confidence in real-world performance expectations. The installation flexibility of mini-split systems provides significant advantages for retrofits of existing homes and specific applications in new construction. Indoor units mount on walls, recess into ceilings, or install in floor-level configurations accommodating diverse room layouts. Refrigerant line sets require only small wall penetrations rather than the substantial duct chases that central systems need. The ductless approach enables room-by-room or zone-by-zone installation that can prioritize spaces where heating and cooling matter most. Homes with existing forced air systems can supplement with mini-splits in problem areas without replacing the existing system entirely. Annika Hakkarainen Virtanen, a Finnish HVAC engineer who has designed mini-split installations for Nordic residential applications over 15 years, has documented how careful system design dramatically improves real-world performance compared to standard product specifications. Her design approach addresses indoor unit placement, refrigerant line routing, outdoor unit location, and controls integration to optimize total system performance rather than merely installing equipment to basic capacity specifications. The design sophistication particularly matters in cold climates, where system performance margins are tighter than milder climate applications. Her work has contributed to industry best practices that increasingly emphasize design quality alongside equipment specifications. The zoning capabilities of mini-split systems enable independent temperature control for different rooms or zones without the duct damper complexity that zoned central systems require. Multiple indoor units connected to a single outdoor unit can each operate independently, providing heating to some rooms while cooling others if desired. The zoning flexibility suits contemporary lifestyles where different family members prefer different temperatures or different rooms have different use patterns. The zoning capability reduces total energy consumption by conditioning only spaces actually occupied rather than whole home uniform conditioning. Now for the obstacles and limitations that affect mini-split adoption. First, the purchase and installation costs exceed conventional heating system costs in most markets. Typical mini-split installations cost $3,000 to $6,000 per indoor unit depending on capacity and installation complexity. Whole home multi-zone installations can reach $15,000 to $30,000 compared to $6,000 to $12,000 for conventional furnace and air conditioner systems. The cost premium deters some adopters despite operational savings that would eventually recoup the investment. Utility rebates and federal tax credits can substantially reduce net costs in many markets. Second, the aesthetic considerations affect acceptance by homeowners sensitive to visual appearance. Indoor units mounted on walls are visible in interior spaces, differing from the concealed registers that central systems use. The visual appearance bothers some homeowners who prefer completely concealed HVAC equipment, though concealed ducted mini-split options address this concern at somewhat higher costs. Contemporary indoor unit designs have become more aesthetically refined with cleaner lines and more attractive finishes than earlier product generations. Third, the cold climate performance limitations in the coldest regions remain meaningful despite dramatic improvements in recent years. Regions with regular outdoor temperatures below -20 Fahrenheit may still require backup heating during coldest periods. Cold climate mini-splits rated for such temperatures cost more than standard models. The cold climate considerations affect regional market penetration that has generally been stronger in warm climates than in the coldest northern regions. Fourth, the multi-zone system complexity can present operational challenges for occupants unfamiliar with sophisticated HVAC controls. Individual unit controls, system-level controls, and coordination among zones require user adjustment that some find complicated. Professional installation typically includes user training, but complex systems may still produce operational confusion for occupants accustomed to simpler thermostat operations. Fifth, the refrigerant considerations raise environmental concerns that are being addressed through industry transitions. Current mini-splits typically use R410A refrigerant with substantial global warming potential if released. Newer products using R32 and other lower-impact refrigerants are emerging, but not yet universal. The refrigerant issues will diminish as product transitions progress, though they represent consideration for contemporary purchase decisions. Despite these considerations, mini-split heat pumps represent among the most compelling HVAC technologies available for homes across diverse climate zones and application situations. The energy savings from mini-split adoption vary substantially, based on the previous heating system being replaced. Households replacing resistance electric heating achieve the most dramatic savings, typically 50 to 70% reductions in heating electricity consumption. Households replacing oil boilers or expensive gas heating achieve substantial savings reflecting both efficiency gains and fuel cost differences. Households replacing efficient modern gas furnaces achieve more modest savings that may not justify investment costs based purely on operational economics, though electrification and emissions benefits may still support the transition for climate-motivated households. The cooling performance advantages of mini-splits provide value for households that previously lacked cooling or used inefficient window air conditioners. The high-efficiency cooling operation produces excellent comfort at lower operating costs than alternatives, particularly for homes where whole-home air conditioning wasn't previously practical. The cooling capability adds value that affects total investment return analysis beyond pure heating considerations. Ezekiel Okoro Obi, a Nigerian-American HVAC installer who has worked across the northeastern United States for over a decade, has documented how customer satisfaction with mini-split installations consistently exceeds expectations once occupants experience actual operation across full seasons. His customers frequently initially hesitated about visual appearance or performance expectations, but developed strong enthusiasm after experiencing the comfort and efficiency improvements compared to previous heating systems. The satisfaction patterns support continued market expansion as word-of-mouth recommendations from satisfied customers drive additional adoption. The electrification benefits of mini-split adoption align with climate policy objectives and support grid integration opportunities. Households transitioning from fossil fuel heating to electric mini-splits reduce direct emissions from residential energy use. The transition supports broader grid decarbonization pathways as renewable electricity generation expands. The electrification contribution matters particularly for households and communities committed to comprehensive climate action beyond individual building efficiency improvements. The integration with solar electric systems produces particularly attractive combined economics in many applications. Solar electric systems sized to meet household electricity needs can cover mini-split operation during daytime cooling and sunny winter days when heating loads coincide with solar availability. The combination reduces reliance on utility grids while providing comprehensive heating, cooling, and general electricity needs through coordinated renewable systems. The integration appeals to households pursuing energy independence beyond pure economic analysis. Raquel Montoya Vargas, a Colombian-American solar installation company owner who has integrated mini-split systems with solar installations for over 200 households, has documented how combined systems consistently produce better customer satisfaction and economic returns than separate adoption of individual technologies. Her business model recognizes that homeowners increasingly seek comprehensive home energy solutions rather than isolated technology purchases. The comprehensive approach represents emerging market direction that reflects customer preferences for integrated, sustainable home systems. The inverter-driven variable speed operation of contemporary mini-splits produces comfort advantages beyond the energy efficiency gains that specifications typically emphasize. The modulating operation maintains stable temperatures without the temperature swings that on-off cycling conventional systems create. The quiet operation eliminates noise disturbance that some conventional HVAC equipment produces. The consistent air circulation improves indoor air distribution compared to intermittent operation patterns. The comfort improvements contribute meaningfully to quality of life that specifications alone don't fully capture. The dehumidification performance of mini-split systems affects cooling season comfort beyond temperature control. Variable speed operation removes humidity effectively, while maintaining moderate cooling rather than rapidly cycling to satisfy temperature targets. The humidity control improves comfort at higher thermostat set points, potentially reducing overall cooling energy while maintaining or improving comfort. The dehumidification advantage particularly matters in humid climates where comfort depends as much on humidity control as temperature control. The workforce development around mini-split installation has expanded substantially alongside market growth. Contractors specializing in mini-split installation now exist in most U.S. markets. Manufacturer training programs have improved installer expertise. Industry certifications provide quality credentials. The workforce maturation has improved installation quality and reduced the cost and complication that early market installations sometimes produced. Pekka Virtanen-Lahtinen, a Finnish-American HVAC training specialist who has trained thousands of installers in cold climate mini-split installation, has documented how installer expertise substantially affects real-world performance outcomes. His training emphasizes system design, commissioning procedures, and customer education alongside pure technical installation skills. The training program has contributed to installer workforce development that supports continued market growth at high-quality levels. The smart home integration capabilities of contemporary mini-splits include Wi-Fi connectivity, smartphone apps, and integration with major smart home platforms. These capabilities enable remote monitoring, automated scheduling, and coordination with other home systems that produce both convenience benefits and additional efficiency opportunities. The smart capabilities have become standard in contemporary products rather than premium features, making sophisticated operation accessible to most customers. The climate change adaptation value of mini-split installations includes both heating and cooling capabilities that address evolving climate patterns. As extreme heat events become more common, cooling capability matters increasingly for occupant safety during heat waves. The heating capability continues serving winter heating needs, while cooling provides summer resilience. The dual-function capability provides comprehensive climate adaptation that single-function alternatives cannot match. The selection considerations among available mini-split models involve evaluating capacity, efficiency ratings, cold climate performance, and feature sets that affect total value. Heating Seasonal Performance Factor (HSPF) ratings indicate heating efficiency, with ratings above 10 representing high-performance units suitable for cold climates. Seasonal Energy Efficiency Ratio (SEER) ratings indicate cooling efficiency, with ratings above 20 representing high-performance cooling capability. Cold Climate Capability ratings document performance at specific low temperatures that affect suitability for northern applications. The ratings enable informed comparison among products, while cost considerations affect final selection decisions. Saraswati Ramachandran Nair, an Indian-American building science consultant who has evaluated hundreds of mini-split installations for performance and customer satisfaction, has documented how proper product selection matched to specific application requirements produces substantially better results than generic specification approaches. Her evaluation methodology considers climate, building envelope quality, load calculation accuracy, and user preferences in selecting optimal products. The selection sophistication distinguishes excellent installations from adequate ones, with excellent installations delivering the full potential that the technology offers, while adequate ones may produce disappointing performance. The load calculation accuracy affects installation sizing decisions that substantially affect performance and economics. Oversized systems produce short cycling that reduces efficiency and comfort. Undersized systems cannot meet heating or cooling demand during extreme weather periods. Proper manual J-load calculations produce appropriate sizing that matches system capacity to actual building needs. The calculation investment supports good installation outcomes across extended operational lifespans. rather than relying on rules of thumb that may produce suboptimal selections. The commissioning process for mini-split installations affects whether systems achieve their full performance potential. Proper evacuation of refrigerant lines before charging prevents moisture and contaminants from compromising system performance. Correct refrigerant charge adjustment produces optimal operation across varied conditions. Airflow balancing ensures proper distribution throughout installations. Control configuration and user training complete the commissioning process. These commissioning steps add modest labor to installations, but substantially affect long-term performance outcomes. Installations cutting corners on commissioning commonly show performance shortfalls that proper commissioning would have prevented. Mohammed Al-Khoury Nasser, a Syrian-American HVAC technician who has developed specialized expertise in mini-split diagnostics, has documented how many nominal performance shortfalls in installed systems trace to commissioning deficiencies rather than equipment issues. His diagnostic work frequently identifies improper refrigerant charges, incorrect control settings, and airflow imbalances that reduce performance substantially below nominal specifications. The diagnostic findings support emphasis on proper commissioning during installation, rather than accepting assumption that properly installed equipment automatically achieves specified performance. The maintenance requirements for mini-split systems are generally modest compared to complex conventional HVAC equipment. Indoor unit filter cleaning every few months maintains airflow and air quality. Annual professional inspection addresses coil cleaning, refrigerant charge verification, and overall system health. The maintenance investment of $150 to $300 annually helps sustain performance across extended service lives. Neglected maintenance can reduce performance and shorten service life, making the maintenance investment important for realizing the full value of substantial installation investments. The hybrid operation of mini-splits combined with existing heating systems provides transition pathways for households not ready for complete system replacement. Mini-splits handle primary heating during moderate weather, while existing heating systems provide backup during extreme weather or handle specific zones that mini-splits don't serve. The hybrid approach reduces transition risks while still capturing substantial efficiency benefits. The flexibility accommodates households preferring incremental transitions over complete system replacement, particularly for homes with relatively new conventional heating equipment that has substantial remaining service life. The supplemental installation of mini-splits in specific problem areas offers particularly attractive applications for homes with existing central heating that doesn't reach certain rooms effectively. Upstairs bedrooms that stay too hot in summer, finished basements that stay too cold in winter, home offices with limited duct access, and similar problem areas benefit from targeted mini-split supplementation. The supplemental applications deliver focused benefits at relatively modest costs, since single-zone installations cost substantially less than whole-home systems. The targeted approach produces customer satisfaction through addressing specific discomfort issues that generalized solutions haven't resolved. Javiera Navarrete Moreno, a Chilean-American HVAC contractor who is specialized in retrofit supplementation applications across Southern California, has documented how supplemental mini-split installations consistently produce high customer satisfaction through addressing specific problem areas that homeowners have tolerated for years or even decades. Her projects typically involve single-zone installations costing $4,000 to $6,000 that transform rooms from unusable to comfortable while producing modest total energy savings through eliminating whole-home HVAC operation to condition-specific problem zones. The targeted applications expand mini-split market beyond whole-home replacement scenarios. The industry evolution around mini-split technology continues producing steady improvements in performance, features, and economics. Higher efficiency ratings across product generations, lower cold climate operating temperatures, expanding applicable regions. Better aesthetics addressing acceptance concerns, simplified installation approaches, reducing labor costs, lower impact refrigerants, improving environmental performance. The continued improvement trajectory suggests that in-split technology will continue expanding market share across coming years, while products themselves continue becoming more attractive across multiple dimensions that affect purchase decisions. The global perspective on mini-split adoption shows substantial variation across countries and regions. Japan has used mini-split technology extensively for decades. European markets have adopted mini-split technology progressively as heating electrification advances. American markets have accelerated adoption substantially over the past 10 years, but still lag behind similar regions in other developed countries. The global comparison suggests substantial further growth potential in American markets as familiarity and cost-effectiveness continue improving relative to conventional alternatives. The financing options for mini-split investments have expanded substantially alongside market growth. Manufacturer financing programs, utility on-bill financing, and specialized residential energy efficiency financing all support households investing in mini-split systems. The financing availability addresses one of the substantial barriers that affects adoption, making mini-split installations feasible for households without adequate savings for large upfront payments. The financing sophistication continues evolving to support expanded market access across income levels that would benefit from efficiency investments. The cold climate deployment experience from utility programs across New England, the upper Midwest, and interior Alaska provides substantial evidence that contemporary mini-split technology performs reliably in the harshest North American climates. Program participants across these regions consistently report strong satisfaction with heating performance even during extreme cold weather events. The accumulated experience across tens of thousands of installations in these challenging climates validates claims about cold climate capability that might otherwise have seemed optimistic. The real-world performance evidence supports continued expansion of cold climate applications that older generations of heat pump technology could not reliably serve. Consider what mini-split heat pump technology means for households evaluating heating and cooling system options. The dramatic efficiency improvements of 2 to 5 times conventional heating performance produce substantial operating cost savings across system lifespans. The cooling capability provides comfort benefits that may not have previously been affordable. The cold climate performance enables application in regions previously considered unsuitable. The installation flexibility accommodates diverse retrofit and new construction situations. The zoning capability supports contemporary lifestyle preferences. The electrification benefits align with climate policy objectives. The federal tax credits and utility rebates substantially improve economics in many markets. The smart home integration supports modern convenience preferences. The comfort improvements through variable speed operation exceed what conventional HVAC equipment provides. The dehumidification performance improves humid climate comfort measurably. The question isn't whether mini-split heat pumps deserve consideration in HVAC system decisions. The question is why households continue installing conventional HVAC equipment when mini-splits offer superior performance across virtually every measurable criterion. The answers involve initial cost concerns, contractor familiarity, and installation aesthetic preferences rather than fundamental limitations of the technology. For any household facing HVAC system replacement or major upgrade decisions, mini-split heat pumps represent the most compelling technology choice available for most applications.